Okay, I'm going to go over a couple of things. One is, okay, and we use two examples to go over it. So f of x is x to the 5 minus 9x3. So this is the polynomial. Degree is 5. Then the leading term is x to the 5. It's always the degree of x. It's the term with the highest power of x, right? Okay. Now find all the zeros. So we set y is equal to 0. And let's factor this by by GCF. So I'm going to factor out x cubed and x squared minus 9 for the factors. It's a difference of squares. X minus 3 times x plus 3. So we have three things equal to 0. So that means x is equal to 0, or x is equal to 3, x is equal to negative 3. So, and remember from fundamental theorem of algebra, the degree of the polynomial is exactly how many number of zeros you have, including repetition. So we should have 5 zeros, and our zeros are, now x is 0, but it's x cubed. So the zeros are 0, 0, 0. So we see this, we can either say we have the polynomial has a factor, which is basically the form x minus 0, or x minus c, has a factor of multiplicity 3. That means the factor repeats 3 times, which was what we have, x minus 0 cubed, right, or x cubed. Or we also say we have a polynomial which has a 0 of multiplicity 3. So x is a 0 of multiplicity 3, means it repeats 3 times. So, okay, so our 3 zeros are 0, 0, 0. Then we had negative 3 is a 0, and plus 3 is a 0. We have the 5, 0. Okay. Now we know how to sketch this. We said, so you find the intercepts, you can plot them directly. They were 0, 3, and negative 3. Okay. All right. And then we said the simplest way is just make a sign chart with all the factors. I'm going to put x cubed. Okay. X minus 3, x plus 3. So if I were to write out y is, again, this is in factored form. This is x cubed times x minus 3 times x plus 3, right? Okay. Now the zeros of each of these factors, for x cubed is 0 when x is 0. Then the other two were 3 and negative 3. Okay. And then we said just pick, when is x cubed 0? When x is 0. What would be the sign of x cubed if x is bigger than 0? So I plug in a number, 1. 1 cubed is positive. So any number for x bigger than 0, x cubed is positive. What happens if x is less than 0? So negative 1 cubed is negative 1. So it's negative. So any value for x less than negative, or less than 0, x cubed is negative. X minus 3 is 0 when x is a value of 3. When x is bigger than 3, for example, 4. 4 minus 3 is 1, we have positive. When x is less than 3, we put any number, 0. 0 minus 3 is negative. X minus 3 is negative. And finally, for x plus 3, it's 0 at negative 3. When x is bigger than negative 3, let's say when x is 10, 10 plus 3 is positive. So to the right of negative 3, we are positive. And when x is less than negative 3, I can pick x as negative 100. Negative 100 plus 3 is negative. Now, if I were to multiply these factors, 3 negatives will give me a negative. 2 negatives times a positive is a positive. 1 negative is negative, and all positive is positive. Okay. And we would just sketch the graph. To the right of 3, we are positive. So we're going to positive infinity. We come back, left of 3, we are negative. Go below, come to 0. To the left of 0, we are positive. Go above, come back to negative 3. Left of negative 3, we are 0. Okay, so this is what we have done in class. Okay, now, so we learned this new terminology about multiplicity. If a polynomial has multiplicity for 0 is, say the 0 is 5, and it has a multiplicity of 2, that means there are two zeros, 5 and 5. Two factors, x minus 5 times x minus 5, which is basically, I could have written that as x minus 5 squared. Okay. Now, here there is an important thing. We see we can also sketch this graph. There's sometimes we are interested in a graph. The few things we're interested in a graph. First thing, so for a graph, we care about first the domain of the function. For polynomials, it's always negative infinity to infinity. We find all the intercepts. For x-intercepts, that are the zeros, we set y to 0. To find the y-intercept, we set x to 0. Okay. Third thing we did is we do the sign chart and sketch the graph. But there is one thing here in this sign chart and we're kind of not discussing very clearly, is we ask this question, we can be asking the question, describe the end behavior of the function of our graph. End behavior, because the domain is all real numbers, we are asking what happens when x is getting bigger and bigger in the positive direction and bigger in the negative direction. What is happening to the y values? So we'll write it this way. This is as x is going, put an arrow, that means going towards positive infinity. What is y going towards? Okay. And as x is going towards negative infinity, what is y going towards? Now, we know for polynomials in either direction, we can only be going to two places. Either y is going to positive infinity or negative infinity. So what determines it? We say as x is going to infinity or negative infinity, y will approximate or start to look like, remember we said the leading term. What is the leading term in our case is x cubed, right? That's the leading term. So now you just answer the simple question. If x is going to infinity, that means on the right side, x is positive. What's a positive number multiplied 3 times is positive. So we will say y is going to positive infinity. On the other side, though, as x is going to negative infinity, what is y headed to? Y is headed to, now let's say in the negative direction, x is negative. A negative number cubed is negative. So we are headed to negative infinity, which is, we have it right here in the sign chart. In the right, we are going to positive infinity. In the left, we are going to negative infinity. Is that okay? All right. Now, we did not need to describe the end behavior in order to sketch our graph. We just did the intercepts, made the sign chart, sketched the graph. Okay. So there is another way to sketch polynomials, and it's good to know it. Is I'll do this with an example. Say f of x is equal to, I won't do something crazy, x squared times x minus 1 cubed times x plus 1 squared. Okay. And I say sketch this graph. Okay. So we could actually just sketch it directly, right? So sketch. We know the zeros. We're at 0. When is this guy 0? If I set y to 0, that's 0 when x is 0, when x is 1, and when x is negative. Okay. We can make our sign chart. X squared, x minus 1 cubed, and x plus 1 squared. Okay. The zeros of these were 0, 1, and negative 1. Okay. Follow along. Okay. X squared, doesn't matter what x squared is always positive. Okay, except when x is 0, when that is 0. Okay, x minus 1 cubed. So x minus 1 is 0 when x is 1. So let's go there. When x is bigger than 1, say 2. 2 minus 1 is positive, and a positive cubed is positive. If x is less than 1, for example, 0, 0 minus 1 is negative, and negative cubed is negative. We are all negative here. And x plus 1 squared is always positive. Okay, so we have a negative. Here we have one negative, and then a positive. Okay, look at this graph. It's weird, right? So to the right of 1, we're going to positive infinity. Left is negative. Come back to 0. We have to stay negative to the left of 0, so bounce off. Come back to negative 1, and left of negative 1, we are also 0, negative, so we bounce off. That will be the graph. But there is a second way to sketch the graph. First, we look at end behavior. Okay, sorry, second. First, we always find the zeros. So first we do the zeros, which we found were 0, 1, and negative 1. Then we look at the end behavior. Well, what's the leading term in our case? So remember, from all the factors, you peel off the leading term. So first one is x squared, it was x minus 0 squared, times from x minus 1 cubed. If you multiply that out, there will be an x cubed as the leading term. And from x plus 1 squared, it is x squared. So this is actually x to the 5, 6, 7 is our leading term, is x to the 7. Let's describe the end behavior as x goes to infinity and x goes to negative infinity. Y will approximate or start to look like leading term. So if x is going to infinity, y is headed to infinity because positive number cubed is positive. And x is going to negative infinity, a negative number cubed is negative. So y is headed to negative infinity. So we could have done this on the graph. We can put the zeros were 0, 1, and negative 1. To the right, we're going to positive infinity, and we left, we're going to negative infinity. That's all I marked off. Okay. Now, we do one more thing. You will notice that look at our sign chart. Look at the first factor was x. It has a multiplicity of 2. Okay. So where is x? So x squared is 0. So you can think of it like this. The factor is x minus 0. Okay. The 0 is x is 0. Okay. You can see when x went through 0, mean went from below 0 to above 0, x squared did not change sign. It stayed positive on both sides of 0. Okay. If x squared did not change sign, the polynomial did not change sign. You see the polynomial on both sides of 0 stayed negative. Okay? Is that okay? Look at x plus 1 squared. Again, it's squared. Where is x plus 1? 0 when x is negative 1. Let's look. When x passes through, when it's below negative 1, x plus 1 is positive, and above negative 1, it is also positive. Meaning, when x passed through negative 1, x plus 1 squared did not change sign. So if the factor did not change sign, and we see the polynomial also did not change sign. Okay, so let's write this down. I hope I'm not overcomplicating it. It's simple. If factor does not change sign, so let's give me an example. So the x is equal to 0 was the 0, correct? Okay, x minus 0 squared was the factor associated with that 0. Okay, if factor did not change sign, well, something squared will not change sign, then the polynomial or f of x does not change sign. Okay, now that happened twice. Also, when x 0 was negative 1, the factor was x plus 1 squared. The factor does not change sign, so the polynomial does not change sign. As so, if the factor x is 0 is the 0, x squared, x minus 0 squared is the factor. If the factor did not change sign, which is this guy, then the polynomial does not change sign as x passes through the 0, which is 0. So similarly, x is equal to negative 1 is a 0, x plus 1 squared is the factor. Since factor does not change sign, the polynomial does not change sign at the 0 at x is equal to negative 1. Now look at the final 0. Final 0 was x is equal to, 1. Was x is equal to 1. Factor associated was x minus 1 cubed. Now look, when x is 1, to the left of 1, x minus 1 cubed was negative, and to the right of 1, x minus cubed was positive. So the factor x minus 1 cubed changed sign as x passed through 1. And we see that the polynomial also, this is not the right color, the polynomial also changed sign. It went from negative to positive as x passed through 1. So x is equal to 1 is was the 0. X minus 1 cubed is the factor as x passes through 1, the 0, right? The factor changes sign. So the polynomial also changes sign. Okay, that's all there is. Now here is the simplified version. Okay, you look at 0. Okay, and then you look at the factor associated with that 0. For example, 0 was 1. Factor associated with x minus 1 cubed. You see, the power is odd of the factor. If power odd, right, then factor changes sign. That means polynomial changes sign. Okay, if so, you look at the zero, and if the factor, say it was x plus plus 1 squared. If the power of the factor is even, then factor does not change sign. So that means the polynomial also does not change sign. Okay, so thing to keep in mind, if multiplicity of factor is even, then polynomial does not change sign at the zero, associated zero, the zero associated with that factor, correct? Okay, but if multiplicity is odd, then the polynomial changes sign at the associated zero. So let's look at our problem again. It's this guy. I'm going to just do it. So in some ways, actually, this method is faster than our sign chart, but you should know both. And I will like more sign chart. So we did the end behavior. Leading term was x to the 7. X was going to infinity, y is going to infinity, is x is going to negative infinity, y is also going to negative infinity. So we put the two ends, the arrows. We put the zeros down for 0, 1, and negative 1. We come from in positive infinity, hit 1. Look at the factor associated with 1, which was what? X minus 1. The power of that is cubed, so we change sign. Positive, we become negative. Come back to 0. Look at the factor associated with 0 is x squared. The power of that is even, so we don't change sign, so the graph stays negative. When we come to negative 1, the factor associated with negative 1 was x plus 1 squared. Since the multiplicity is even, again, we don't change sign. So the graph was negative to the right. It has to stay negative to the left. So you see, you can sketch the graph of a polynomial function in two ways. One, by just looking at the sign chart. And two, by looking at the end behavior and the multiplicity of the factors at the zeros, right? If the multiplicity is even, you don't change sign for the graph. If the multiplicity is odd, you change sign. Okay, that's it.